Welcome everyone. We are discussing binomial theorem. Today I will discuss how to find coefficient of any term. Coefficient of any term. First, I consider two simple problems. So, problem number 1. Find coefficient of x square in 2x square minus 3 by x whole to the power 11. Now, if we expand it, we get 11 plus 1, 12 terms. Then simplifying 12 terms, we get coefficient of x square. If there is any term having coefficient of x square, but it will be lengthy. So that is why we use general method. So let tr plus 1th term contains x to the power 2, x square. So tr plus 1, you know this is general term, 11 cr. If it is r plus 1, 11 cr. 2x square to the power 11 minus r minus 3 by x whole to the power r. Now this one is 11 cr. We are writing coefficient. Constant term first, 2 to the power 11 minus r minus 3 to the power r minus 3 to the power r, and this is x to the power 22 minus 2r by x to the power r by x to the power r. That is, if we take it directly, we get 22 minus 2r minus r. That is 22 minus 3r. Now, according to problem, these must be x square. So, given condition, x to the power 22 minus 3r equals to x to the power 2. So, bases are same, 22 minus 3r equals to 2. So, 22 minus 2r. So, 22 minus 3r equals to x square. So, we are getting 3r equals to 20. So, r equals to 20 by 3. So, this is not integer. So, does not belongs to I plus. This is not positive integer. Term cannot be fractional. So, we are not getting any value of integer r. So, coefficient of x square. There is no term involving coefficient of x square. Since this is not possible, what will be our conclusion? There is no term involving x to the power 2. If r is integer, we can say that there is term having coefficient of x square. So, listen again, you find tr plus 1, simplify, and this equals to x square. Now, A problem is find coefficient of x in the expression this. So same procedure, let tr plus 1 term contain x to the power 1. So same calculation, given condition, this equals to x to the power 1. So this equals to 1. So 3r equals to 21. So we are getting r equals to 7. So we are getting integer value. So what is r? R equals to 7. Therefore, tr plus 1. So t8th term contains x to the power 1. Now what is t8? 11 c 7 2 to the power 4 minus 3 to the power 7 into x to the power 22 minus 3r, so x to the power 1. So this will be coefficient. This will be coefficient. So take general term, equate the coefficient. If it is positive integer, then coefficient is possible. But here coefficient of, in case of x to the power 2, we are getting r equals to fraction. So no term involving x square. If it is x to the power 1, you can find coefficient. That is, 8th term will be the term having coefficient x to the power 1. Now, these are simple and basic problems. Now, second one. Find coefficient of x to the power 6 in this. This is simple one. So, you solve it. So, same way. So, look, this will be our step 9cr 3 by 2 x square whole to the power 9 minus r minus 1 by 3x whole to the power r. So write the constant term at first. 3 by 2 to the power 9 minus r minus 1 by 3 whole to the power r. Now x to the power 18 minus 3r, because 18 minus 2r minus r. Now given x to the power 18 minus 3r equals to x to the power 6. This implies 18 minus 3r equals to 6. So 3r equals to 12. So r equals to 4. R equals to 4. So T5. What is our T5? 4 plus 1. 9c4. 3 by 2 whole to the power 5. Minus 1 by 3 whole to the power 4 into x to the power 6. So coefficient equals to 9c4. This is 1 by 2 whole to the power 5 into 3. Minus 1 to the power 4 is positive. This is 3 to the power 4. This is 3 to the power 5. Coefficient of x to the power 6. 9c4 into this. Simplify and you get the result. So, these are very simple. Now, I consider problems of competitive exam. Now, we consider 3 problems, 3, 4 and 5. Find coefficient of x in this. Find coefficient of x in 1 minus 3x plus 7x square into 1 minus x whole to the power 16. Find coefficient of x to the power minus 1 in this. So consider the fifth one. This is simple one. You look, this is 1 plus x, and if you take LCM, you get also 1 plus x. So if you simplify, this is 1 plus x whole to the power n. This is x to the power n, 1 plus x whole to the power n. So simplifying 1 plus x whole to the power 2n by x to the power n. Now look, you have to find x to the power, coefficient of x to the power minus 1. So, coefficient of x to the power minus 1 in this expression. Now, this is binomial expression. If we find coefficient of x to the power n minus 1, so look, in numerator, if we take coefficient of x to the power n minus 1, then denominator is x. So, if we simplify, we get 1 by x. Now, to find coefficient of x to the power minus 1 to this expression, you have to find coefficient of x to the power n minus 1 in 1 plus x whole to the power 2n. Because, look, x to the power n minus 1 by x to the power n equals to 1 by x. So, coefficient of x to the power n, x to the power minus 1 in the expression equals to coefficient of x to the power n minus 1 in 1 plus x whole to the power 2n. Now, one term is 1 and another is x. So, this is very simple. No need of taking general method, because first term is 1 and second term is x. So, 1 plus x whole to the power 2n. So, Tn, if we find Tn, then we get 2ncn into 2ncn minus 1 into 1 to the power difference of this, that is 1, and x to the power 2n minus, n minus 1. Look, we have to find coefficient of x to the power n minus 1 in 1 plus x whole to the power 2n. For previous problem, we use general method, because first term contains in term involving x and second also involving x. But here first term is 1, second term is x. That is why we are not using general method. Now, what is coefficient of x to the power n minus 1? So, therefore, coefficient of x to the power n minus 1 in the expression equals to coefficient of x to the power n minus 1 in this. So, what is the coefficient? So, we have already calculated it. This is 2ncn minus 1. 2ncn minus 1. So, look it again. So, look, 1 plus x. This also 1 plus 1 by x. That is why we are taking LCM. And power will be added. So, we are getting very simple problem. But if it is minus, then it will be difficult. So, now problem number 3. So, find coefficient of x in 1 minus 2x cube plus 3x to the power 5, 1 plus 1 by x whole to the power 8. So, here also first term is 1. So, look, if we expand this term, we get terms are 1, 1 by x, 1 by x square, 1 by x cube in this way. That is, since it is 1 by x. So, x will be obtained if we multiply 1 by x, 2 by 1 by x to the power 4, 2x cube by 1 by x to the power 4, and this is 3 x to the power 5, 1 by x to the power 6. So, we need these terms. So, expand it. We get 1, then 8c1 into 1 by x, because first term is 1. 8c2 into 1 by x whole square. 8c3 1 by x whole cube. Then 8c4 1 by x whole to the power 4. 8c5 1 by x whole to the power 5. 8c6 1 by x whole to the power 6. 8c7 1 by x whole to the power 7. Then 1 by x to the power 7. Now this to be noted. We need coefficient of x. So look, when 2x cube is multiplied by 1 by x to the power 4, we get 1 by x. Now 3x to the power 5, when it is multiplied by x to the power 6, we get 1 by x. And 1 multiplied by x, we get x. But there is no term here involving x. So we are getting only two combinations. Therefore, coefficient of x equals to minus 2 into 8c4 plus 3 into 8c6. Then simplify, minus 2, 8, 7, 6, 5, 4, 3, 2, 1. Factorial 4 cancel out. 8, 7. Factorial 6 into factorial 2. So look, this is 4. And this is 4 into 2, 8. 3 into 2. So, minus 14 into 10. Minus 140. 14 into 10. Plus. This is plus 12 into 7, 12 into 7, that is 84. And if we simplify, this is 6, this is 6, minus 56, minus 56. So what is coefficient of x? Coefficient of x is minus 2 into 8c4 plus 3 into 8c6. Listen again. Here first term is x, second term is 1 by x. That is why we are using expansion method. But if these and these are both in terms of x, we have to use general method. Now problem number 4. This is of same type. This one unchanged and expand it because it is 1 and second one is x. You can easily solve it. So this is your home task. Then next problem. Now we consider two problems. So these are problem of JEE Main. So find coefficient of x to the power 5 series 1 plus x whole to the power 21, 1 plus x whole to the power 22, 1 plus x whole to the power 30. So this one is series, GP series. And second one, find coefficient of x to the power 50 in 1 plus x whole to the power 1000, x into 1 plus x whole to the power 999, x square into 1 plus x whole to the power 998 plus x to the power 1000. So here look, it is sum of terms. So they are problems of sum of GP series. So look, this is A and common ratio is this by this. So 1 plus x will be common ratio. Now, sixth one is very simple. We consider 17. So, you first find the sum of the series S. A into r to the power n minus 1 by r minus 1. So, what is A? A is first term. 1 plus x whole to the power 1000. Now, what is r? This by this. So, we are getting what is r? R equals to second term by first term, third term by second term. So, x by 1 plus x by 1 plus x. So, x by 1 plus x minus r to the power n whole to the power n minus 1 by x by 1 plus x minus 1. So, this is sum. But how many terms? Look, terms are here 1 plus x whole to the power 1000, 99, then 1 plus x whole to the power 1, then 1 plus x whole to the power 0. So, 1001 number of terms, not 1000 terms, 1001. N equals to 1001. Look here also x to 1000, that is 1000 terms, and here x to the power 0. So, N equals to 1001. R is common ratio. So, what we are getting? 1 plus x first term whole to the power 1000. A into, now this is 1 plus x whole to the power n and x to the power n minus 1 plus x whole to the power n. So this is x to the power n, 1 plus x this. Then 1 plus x by x minus 1 minus x. So this is by minus 1. By minus 1. So we simplify it. So what is n? N is 1001. 1001. This is 1001. This is 1001. Now we have to simplify it. Now this is 1001. So we can write it as. So look, this and this is cancel out. This and this is cancel out. This is 1 plus x. This is 1 plus x. And 1 plus x will be cancelled out. So finally we are getting, so this is minus 1 plus x whole to the power 1001 minus x to the power 1001. So this minus is absorbed, this one. So we are getting s in this form. Now we have to find coefficient of x to the power 50. So coefficient of x to the power 50. So this is only one term, so no x to the power 50. So binomial expression. So if we write this as 1 plus x whole to the power this, then T51. For this term, we can write 1001 C50 into x to the power 50. So what is coefficient of x to the power 50 equals to 1001 C50. There is no term, this is only single term, so no x to the power 50, it will be obtained from this. First term is x, so no need of taking general method. Find T51 and you get coefficient of x to the power 50. So answer is 1001 C50. So write the result in this form. Do not try to expand. So find the sum, simplify and find coefficient. So sixth one is exactly same and the simplest one. So today through this class I have discussed how to find coefficient of any term of binomial expression. So these are most important for competitive exam also. Thank you.